have noted, or in the last lesson, I don't know if you're watching this right away on the same day, but you might have noticed that I was a little excited about this Pascal's triangle thing. Still am, just so you know. But Pascal's triangle is just an item of beauty. It's got so many patterns in it, and it will come up a few times in this course in the second half where we'll just notice a pattern pop out again, and it will relate back to Pascal's triangle. So today we're going to play around with some useful, interesting ways of using the concept of Pascal's triangle, okay? All right. So first of all, let's look at the rows of Pascal's triangle that contain only odd numbers and see if there's a pattern to these rows. And are there any rows that have only even numbers? Why or why not? Okay. Are there rows that contain only odd numbers? So this is only odd. This is only odd. This row right here has an even, so nope. This one has only odd. This one is got a 4 and a 6, which are even. This one's got a 10, which is even. 6th row, well, 6, that's not even. Next one, 7, row 7. I'll check that out. That's all odd numbers. Row 8, nope. Row 9, nope, because it was 36. Row 10, nope, because of the 10. What rows are we looking at? 0, 1, 3, 7. Where do you think the next one will be? There is a pattern. I'm going to leave it up to you to see if you can find the next one, okay? And see if you can note an equation that would be represented in that, okay? So some kind of equation that would tell you the next row, and then once you found the next row, what would the next row be? It's an interesting pattern. Yeah. So try Googling Pascal's triangle and see if you can find the next row so that you can find for sure a row that works. Okay? So this is a little homework question for you to figure out. Okay, let's move on to another type of question. How many different ways can the word lemon be found in this diagram? Let me just draw a couple examples. So right there is a path that spells lemon. And one of our rules here is we're only going to go left or right. We're not going to skip from this E to that M because that's ridiculous. But we can skip from that E to this M, or we can skip from this E to this M. Those are all good paths to take, okay? All right, you could also go like this, zigzag, zig, right? So we have a bunch of options here. So how many ways are there to spell it? Well, let's picture it this way. What if I only had this right here, and I was just trying to spell the word Lee? Or you can see that you'd have Lee spelt this way or Lee spelt that way. So there would be, to spell Lee, there would be 2 ways, right? Okay. Whoops. Okay. What about how to spell lem? Because that's a pretty cool word. So we can spell lem this way. We spell lem this way. Hope you can see that. You can spell lem this way, and you can spell lem this way. So that was, you see that there was one way to get there. To get to this M, there were 2 ways, and to get to this M, there was 1 way. 1, 2, 1. So total, there were 4 ways we could spell lem. Are you seeing a pattern yet? Is that Pascal's triangle popping in there? What if I were to write over top of this? So if I'm just looking to spell the word L, I get 1 way. If I wanted to spell Lee, I could go this way or this way. To get to an M, I would go here. Or I could have 2 ways to go to this M. Okay, and why is that? Well, that's because you can go from this E or from this E. I don't know if you can see what I'm doing there. You can go from this E or from this E down to the M. Okay, and then the last spot here is, is this m, which is 1. So if you see this, I got a 2 here, a 1 there, and a 1 there. Okay, what about to spell lemo? That's a weird word. Say it twice. Okay, to spell lemo, well, you could come from this 1, or you could come from that 2, which would give us 3 paths. And to go to this O, you'd either come from that 2 or that 1, and that would give you 3 paths. And then the ends, there's only one way to get to this N, and that's coming from the O above it. This N would have 2 paths going to it, so that's 6. And this one would have 3 paths. Okay, so that gives us lemon can be spelt in 3 plus 6 plus 3 ways when we look at those different methods, and we get 12 ways to spell lemon. And see how we're using the concept of Pascal's triangle there? All right, let's try another problem like this. To keep track of all students who walk over to Timmy's rather than shopping at the school store, Mrs. Waters mapped out all the paths through the park and surrounding neighborhood. How many different routes could students take, assuming they always are moving towards, what's that, Timmy's? Okay, so let's picture this. Students are right here, and they want to get out to Timmy's. And the rule is they always need to be walking toward Timmy's. So in other words, you can't go this way, down here, and then head that way, because going this way would be moving away from Timmy's, which is right there. You could only move that way in this direction. So what I suggest we do is we always move left to right, okay, on this diagram, and we go to each intersection. So this is the first intersection that is left to right. And so you could come up here, and there would be one way to get there. Next intersection is right here, and this would only give us one way. Now, to get down to this next intersection, again moving left to right, you could have come up here, down here, and down there, because those are all moving towards, or you can go this way right there. So we can use all those paths to help us get there. So we could have coming down there, or we could just go straight across. And so there's one way to go this way, and there's one way to come from up top here, so that would give us 2. All right, next intersection right here. Well, you could go up here, or through here. So again, we're just going to take these numbers, the paths that went to the previous intersections, add them up to get 2 plus 1 plus 1, which is 4. Again, move left to right, up and down. So here you could come from there. You would have 4 ways. Here, this is interesting. You could come from here, or you could come from up here. So there's actually 8 ways to get to that spot right there. Next spot, or you could come around here, or you could come from up there. So there are 4 paths coming from up there, and 8 coming from here, so you get 12. Okay. Next one, left to right, up to down, okay, because Timmy's in the bottom here. So you could come down here, or you could come across here. So we got our 4 up here and our 8 that are heading in these directions. So that would be 12. Next intersection, so you could come from up top or from the left. That would give you 24. And lastly, you're at Timmy's. So you could have come around here. So that would give us 12 ways. Or you could go straight across here, which is 24. So that gives us 36. There are 36 ways to get from SCH to Timmy's. And no, this is not an actual map. I made this up. All right, let's move on to another one here. Build a new version of Pascal's triangle using the formula that generates terms in Pascal's triangle. But start with t sub 0, 0 equals 2. So we're going to start at the top with 2 rather than the standard 1. Build a triangle exactly from row 0 to 5. Let me move it over here. So you get 2. Next row would be 2 and 2. I want you to pause the video and try and do it on your own now for a second. Okay, here's what we would have from here. 2, 4, 2. Next row, 2, 6, 6, 2. Next one, 2, 8. Whoops. 12, 8, 2. Next row, 2, 10, 20, 20, 10, 2. Oh, I'm wondering now, am I following the instructions from row 0 to 5? So this is 0, row 1, row 2, 3, 4, 5. Oh man, I'm good. I should be a math teacher. Okay, that's row 5. Let me get that better. There we go. That's row 5, built from row 0 to row 5. Identify a pattern related to the terms of the new triangles. Okay, pause. A little homework question for you, okay? Try this out. See if you can do it. And then identify a pattern related to the sum of the terms in each row. I know you can figure this out. So remember last time, the sum of the rows, let's see, was 2 to the power of n, right? Well, figure it out on this one. What do you think that relationship is? See if you can figure it out. Pause the video, try it out. Okay, one last question for today. In both cases, Dominic is standing at the northwest. Just in case you don't remember, directions, here's north, here's west. So here's Dominic. We'll call him Dom. Okay, and here again, there's Dom. Okay, he can travel east. That would be this direction, and south, which would be that direction. How many different paths can Dominic follow to the southeast corner of the grid? So this is the ending point for both of them. Okay, so let's start with this one over here. So Dom starts here. I'm going to move up and down, left to right. Okay, so he has one way to start at home, end at home, and that is just stay there and never move. He could come down here. He could go down here. There'd be one way. He could keep going down. That'd be one way again. He could keep going down one way, and he could keep going down. Notice that to get to the bottom left corner, the only way he could do that was just to shoot straight down these streets here, this path. That'd be his only way. Okay? Next, top to bottom. So he could come across and go here. Now if he were to go down here, he could come through this path right here or this path right here. So what that does is it adds one option from here and one option from there. So that gives him 2 there. Here he could come down or he could come across. So that's 2 plus 1, which is 3. Again, he could come down or across. That would give him 4. Again, come down or across. We got 5 at this intersection. Down or across. And we got 6. Okay, next spot here. So you could come across still farther. Well, again, he's just going straight across right here. There's no other option but to go straight across. All right, next spot. You could do this, or you could come down or across. So this one is a 3. This one, down or across, which gives us 6. This one, down or across, which gives us 10. This one is tricky. You cannot come down because there is no road there. So the only thing coming across is the 5. And here we can come down or across and we get 11. All right, I'm going to fill this in a little quicker now. So we got 1, 4, 10. Again, you can't come down here. So it's just across. 10. Down or across. 15. 26. Next one. 1. 5. 15. 25. 40. And 66. I hope I got all this math right. Sometimes I drop a number. Yeah, it's a little confusing. 1. 6. 21. 46. 86, and then 86 plus 66 gives you 152 ways. pretty exciting, actually. You could almost do a unique path for half a year if you had this as your grid to get from wherever he's going. I hope it's ice cream on the other side. That'd be fun. All right, let's try this next one here. Actually, pause the video, see if you can do it on your own, and then I'll put the answers here in a minute, and I'll walk you through it. All right, here we go. So 1, 1, 1. I'll put a spot here, but 1. You don't need to. 1, 2, down or across, 3. This one only has coming down, so it's that 3 again. This one only comes down, so 3. And this we got down or across, which is 4. Next one, 1, down or across, 3. This one only has coming across, so that's a 3. This one down or across, 6. Down or across, 9. Down or across, 13. Next one, 1. Down or across, 4. Same thing, 13, 22, and 35. Last row here. So 1, down or across, 5, down or across, 12, down or across, 25. And the last one is a sum of 25 plus 35, which is 60. And notice that this one just missing one more column and having a couple more open spots, like right here and here and here, has resulted in much less options. Sad for Dominic. All right, so what I provided for you in your handout is a bunch of the questions from the textbook so that you don't have to copy it out into a book, and you can just use these. So you'll see that these line up with some of the questions that you have to do for your homework. Have fun playing around with Pascal's triangle and applying it to interesting examples.